Hi there, and welcome to another Sontay webinar, this time on environmental sensing in data centers. Just going to wait for a couple of people to join online. This is recorded and it'll be available afterwards from Sontay. So we're just going to do some introductions, who I am, while we just wait for a couple of stragglers to join, and then we'll get into the content. Like I say, you can always review this afterwards. It'll be made available from Sontay. So the first thing is me, Andy Camsell, my favourite subject. So I don't work for Sontay. Obviously, I do work for Sontay. I actually work as a partner in a systems integrator. I've been doing BEMS for a very long time now. Worked it out the other day. It's over 30 years now that I've been doing BEMS. And prior to that, I was an air conditioning and refrigeration engineer. And in terms of the experience in data centers, this makes me feel really old because I was doing air conditioning at a time when data centers didn't really exist. People were turning rooms of their buildings into data suites. They had these huge things called Winchester drives, some of them with as much as 40 megabytes of storage on a thing the size of a table. And those data suites have obviously evolved into what we now see as a modern data center, a very modular setup in terms of the data itself, the way everything is racked, the way that air flows through that data center. And alongside that, of course, we've seen the criticality has gone from being very critical to incredibly critical and secure in data centers. So I've seen a lot of change in that environment in my working life. Some things have stayed the same, and you will be unsurprised to learn that sensing technology in those data centers is one of the things which is a constant. It has always been important, and it still is. So just to talk about this webinar itself, it's a series of PowerPoint slides. There is a Q&A which is open on Vimeo. If anyone is here and they want to interact, then there are people at Sontay. There is actually Phil Berry and Lizzie, who are from Sontay, waiting in the wings. If you've got any questions, they will take those for you and answer those as we go along. I try and keep an eye on the chat while I'm here. Got a lot of windows open on my screen to field any questions that you might have as we go along. Going to talk about a number of key points in terms of data sensing technology or data centers, the sensing technology that we have in there. One of them is, of course, protecting uptime. They are critical environments, and so they have to keep running, and sensors play a key role in that. We're also going to look at what you might want to monitor in a data center. I think most people who work in data centers are quite familiar with that, but if you're new to data center monitoring, data center control, there's a couple of things there that you might not have considered in terms of what you need to monitor in that data center itself. Also looking at choosing the right sensing technology. What do we need to adequately monitor a data center? Redundancy as well. So when we talk about redundancy, it's having a system where we have backups, we have standby components for anything which fails. And it's quite a complex task to add redundancy into a BEMS because they are not intrinsically redundant systems. And so not only do you need to think about how the BEMS can be changed over or failed over to another system, but how the sensors that are connected to it can also do that. And that obviously means duplication on a lot of systems to create those redundant systems. I'm also going to have a look at the area of sustainability with regards to data centers. There are more and more data centers popping up all over the place. The UK is currently building a lot of data centers. They use a lot of energy, and so we have to think very carefully in our insatiable appetite for K-pop demon hunters how we are actually going to run these data centers and stay on course for our net zero goals. And even if the net zero is a way off, we still need to constantly be thinking about how we can drive energy efficiency into this to drive costs down, but also for those environmental factors. So why does environmental sensing matter at all? I don't think anyone's really asking that question in their head. heat is the big one. Data centers produce a very large amount of heat. The computers that are running in there, the servers that are running in there produce enormous amounts of heat. You also have other systems in data centers which are producing a lot of heat as well. Not least of which is the UPS, the uninterruptible power supplies. Data centers will tend to have at least 2 power supplies and a generator power supply coming into them, but those come into an uninterruptible power supply so that when you're switching from one power source to another or on and off the generators, there can be no interruption to the power, hence the UPS, the uninterruptible power supply. These generate a lot of heat as well, and so we need to remove heat from those areas. Another thing we need to think about in data centers is humidity sensing. Humidity it needs to be managed in data centers for a very specific reason. It's quite counterintuitive, or I always think it's quite counterintuitive, because you think of humidity as being a moist environment, so a lot of humidity would be bad for computers, and of course it is if you've got very, very high humidity. But low humidity can also be very bad for a data center environment. The reason being that low humidity or low relative humidity is an environment in which static discharge or static will discharge more easily if you've got a statically charged body. So if you are in a data center and you are statically charged, you are more likely to discharge if the relative humidity is low, and that can damage the circuits, it can damage servers. So we tend to actually humidify data centers because inherently they have no humidity of their own. There's no people in there, so no one's breathing in there to add to the humidity. So we tend to actually have to add moisture to data centers to keep them humidified, just to prevent that environment where static discharge is likely to occur. There's other things with data centers as well, away from the data halls themselves. We think a lot about airside control in data centers, and rightly so, because that's where all the servers are, that's where all the equipment is. But we also have to think as well about how that is cooled. And of course, you've got chillers, you've got cooling towers, you have a water distribution system which is moving water around that. That needs to be temperature controlled, and the flow needs to be controlled as well. So we have valves which will open to allow more or less cooling into a space. And of course, the flow of water around the system will dictate how fast or slow the pumps are operating in a modern system where we've got 2-port valves. So there's a lot of monitoring and a lot of control that goes into a data center, and the redundancy applies to all of that. So we often talk about 2N or N+1 characteristics of data centers. So you have your equipment which is duty, and then you have standby equipment for everything as well. This bit here, this tight environmental tolerances to protect uptime. There's a weird thing with data centers where there is a general perception that close control isn't important. And when I say close control, what I mean is that when you are working with pharmaceutical environments and certainly electronics manufacturers, so silicon chip manufacturer, things like that, everything needs to be controlled very, very precisely, because any deviation in the environment will result in a deviation of the product, whether that's a semiconductor or the pharmaceutical. In data centers, there's actually quite a broad range of temperatures that we can work within, but that does not mean that we shouldn't be aiming for tight tolerances. And as we're going to see in the slides that are coming up, if you can control accurately, then that's a great way to save energy, because if you don't know what the temperature is in a data hall, then how do you ever hope to control it? So we need to be able to have tight tolerances. We need to have accurate sensing technology. And of course, there's other things that factor into this as well. So we have regulatory compliance, SLAs, service level agreements with customers. We need to keep environmental conditions within certain levels. We also have that regulatory compliance. We have to meet with certain objectives, with energy efficiency objectives to comply with the law. But also there are other accreditation schemes, things like BREEAM and LEED, which it's always good to be aligned with those sustainability goals. Because if you're aligned with those sustainability goals, then of course that would hopefully lead to more business, where people are trying to, or they're striving to achieve their own environmental goals by using companies who are aligned with their goals. Then of course, you have that benefit built in. You're using companies and you're using services which are already aligned with your own environmental goals. This one here, so poor monitoring leads to costly outages. The amount of money that can be lost through a data center outage is absolutely phenomenal. It is huge. Obviously, things like financial services rely heavily on data centers. If things go wrong, that can lead to enormous fluctuations. I say losses, it can lead to huge losses. It can actually lead to huge gains, but what it leads to is uncertainty. So it can have an outage could be really costly, because you need to find out what happened during that outage. So although the redundancy is built into the server equipment itself, etc., the environment is really important. We need to maintain the correct environment to avoid those outages and, of course, avoid the costs associated with them. Things that we monitor within a data center. The main one is temperature. There is a lot of temperature sensing. That's true of all environmental monitoring everywhere, but temperature is a key thing, because servers generate a huge amount of heat, and of course we need to remove that heat from the data center. Otherwise everything's going to overheat, it's going to melt down. We need to do that in a lot of ways. We've got the rack, aisle and ambient temperatures here. So that's looking at air temperatures, but of course chilled water temperatures need to be monitored closely, as well as do things like condenser water temperatures, where you've got chillers in your building. That will have a condenser, or is likely to have a condenser water system, which is going up to cooling towers. So all of that needs to be managed as well. So temperature is a huge part of this. As I mentioned as well, relative humidity, certainly in the data hall itself, is important. When we are adding fresh air into a commercial office building which is populated with people, we need to provide enough fresh air for those people to be able to breathe easily and function normally at work. There's a much lower requirement for ventilation in a data center because there's no people. You still need to change the air in there, because otherwise it would get very stale, but you do need to change the air, but you don't need as much fresh air. Because of that, the air tends to be recirculated much more in a data center. It strips the moisture out. We're cooling this. When we cool it, the moisture in the air condenses on the cooling coils, and that drains away. Obviously, the relative humidity, the absolute humidity, and then the relative humidity as a result comes down. So we often have to monitor the relative humidity, and then quite often with data centers actually add humidity in there. Airflow and differential pressure. Now, the airflow and differential pressure, the differential pressure side of it, that can come in with pumps. We have flow monitoring for our pump sets as well. So there's a lot of things that can factor into the water side of this. But in terms of the airflow monitoring, you would normally want to see some kind of pressure regime maintained in a data suite environment, because you want to have that under positive pressure, so that when someone goes in, someone opens a door, it doesn't suck a load of dirt in, which could affect the systems inside. You want air to be pushed out. So knowing what the pressure regime is, certainly not as important as laboratories, but you certainly want to ensure that you have the correct pressure regime in your data center, as much as you would do anywhere else. And a really big one is water leak detection. Now, this is everywhere in data centers. You don't often see it because, of course, where we want to sense water leaks is normally where we can't see a water leak. A lot of data centers, as many of you will know, have got raised floors in them. So you have a raised floor, you have crack units, computer room air conditioning units, which blow air under the floor. There's lots of different setups, but this is a very typical one. Air is blown under the floor, and then that air comes up between the racks. The air comes up into what is known as a cold aisle, and then the air is drawn through the servers and out into a hot aisle, where it's discharged at high level and it goes back to the crack units. So we've got this false flooring that we're pushing air underneath. Under there, of course, that is where water is going to accumulate. So water leak detection under the floor is critical. If we get water building up under the floor, that is where all your cables are running. You could certainly get a huge amount of problems if you have got water accumulating under the floor. You wouldn't see it until there's a huge problem, and it would be a huge problem. But we want to do more than that as well. So water leak detection is very often built into the air handling units, into the crack units themselves. So we get a very early warning. Tiny leaks, like really minuscule leaks on chilled water systems, chilled water coils, or even condensate overflowing a drip tray can be hugely detrimental. So leak detection is a really important factor when we are looking at data centers. We also look at monitoring critical safety systems. Now, there's a lot of different ways that you can monitor your critical safety systems. Some of those are based around the technology that you're using within the data center itself. So some of it's reliant on the servers, particularly if you're using cloud services such as Azure, Amazon Web Services, Google Cloud, things like that. They have their own monitoring for the server environment. But we also need to monitor the environmental conditions, the actual physical conditions in that space. When we have high temperatures, when if someone were to press an EPO, an emergency power off button, tend not to have a lot of those in data centers these days because it's very easy to press one accidentally and cause a very large shutdown. But things like breakers in a data center, you will have a PDU, a power distribution unit. That has got a load of MCBs, miniature circuit breakers in it. You need to know if those circuit breakers have tripped, if there is a problem with the electrical supply in there as well. So we need to do a lot of monitoring. So there's a lot of things that we actually need to monitor within a data center, as well as the temperature, the humidity, the leak detection, the physical status of various components. In terms of the sensors, where to place sensors, the short answer to this is everywhere. You can never have too many sensors in a data center or in any environment. The more information you've got, then the more useful that's going to be when you are trying to analyze that data. So having as many sensors around as possible is going to be really important to the overall control strategy, the overall monitoring strategy, and certainly the analytics. Now, the reason that is going to be important is because this is a data center that is using a phenomenal amount of energy. If you have got lots and lots of highly accurate information about every component there, then you can make sensible decisions about how to change the operating environment without causing any issues to the data center itself. So let me just give you an example of that. Going back to, like I said, people were using these Winchester drives, huge things. That technology has gone, and now modern servers have replaced them. Those old Winchester drives needed to be kept cool. The room had to be at 18 degrees C. You would not keep a modern data center at 18 degrees C as a standard temperature across the data hall. Modern servers will run at higher temperatures, so it's a given that as equipment is replaced, maybe its operational parameters, its environmental parameters change with it. So you need to have as much information around as possible to say, right, okay, we've got these new servers in, they can now run at 5 degrees higher within these particular parameters. So having all of that information and being able to ensure that that environment is properly maintained at that higher temperature, less cooling, less money, more sustainable. So having as much sensing as possible is really important. In terms of what you might want to sense, you're often looking at delta temperatures, differences in temperatures. We've got here hot aisle versus cold aisle. What is the temperature difference across the racks? So you have cold aisle monitoring and hot aisle monitoring. How much heat is a server or a rack putting out? What are those temperatures in there? What should they be? In-rack versus ambient, the actual in-rack temperature can be important. It very much depends on the server technology which is in use, but what's going on inside the server rack itself can give you very useful insight as to whether you need to provide more or less cooling to that. And another thing which is quite important is height level monitoring. we have this phenomenon of stratification, which I'm sure most people are aware of, but hot air rises. And so data centers tend to have reasonably high ceilings, and therefore you've got warm air at the top and cool air at the bottom. You need to understand what that stratification effect is, particularly if you've got high ceilings, so that you can look at how you can manage that system. It may be that actually you've got quite a lot of hot air at high level, but it's not affecting your racks. So you can actually reduce your cooling because you know what the stratification effect is across your data hall. And when you are looking at this, of course, there is a cost to it. You could buy as many sensors as you want, but each one of those sensors is going to cost you. It's the cost of the sensor, but it's also the cost of the wiring back to a BEMS or some kind of monitoring system. That monitoring system needs to have the capacity to hold that. So there's cost attached to these. So it's all about balancing the coverage that you need to give you the information that you need against the cost of installing that. One thing I'm always curious about with data centers is that when people are putting data centers together, they seem to want to cut costs like right to the bone. These are data centers which are going to make phenomenal amounts of money very quickly, but everybody wants to cut costs when they're installing it. I kind of get that, but in the long term, if you think about the life cycle costs, adding more sensing technology in there, better, particularly temperature sensing across your entire data hall, is likely to pay dividends as time goes on. This is about the accuracy of sensors and calibration regimes which we should have in place. The reason that this is important, I've already sort of stated this, is that when we're doing very close control, things like pharmaceuticals, laboratories, silicon chip manufacturer or semiconductor manufacturer, we very often are, required to have very, very tight tolerances. So everything needs to be, it's often referred to as a validated environment. We have to check and check again. Everything has to be calibrated properly. UCAS, UK Accreditation Service, are often involved. The sensors need to go off to a UCAS accreditation laboratory, come in, and then we test and we retest and we retest so that everything can be controlled very, very accurately. Although we don't need that same level of close control, so we can have a broader range of temperature fluctuation, whereas in a semiconductor plant it might be 0.05 degrees C difference will have a significant impact. That wouldn't affect a data center, but we still need accurate information. If you don't have accurate sensor information, how are you going to control this space? Again, it's unlikely in a data center that a fluctuation of 2 degrees C is going to cause all your servers to melt down. Could if you're running it to the wire, but you'd have to be pretty on board to be running it that close to the wire. But 2 degrees C probably not going to affect you. But if you don't know what the temperature is, how can you improve the efficiency? So higher accuracy results in a smaller error. Smaller error equals better efficiency, because you know that when you apply a strategy to try and save energy, the results you're getting are the results that you're expecting, and therefore it makes it more efficient. You're using less energy. Having a calibration schedule is pretty critical. Most data centers will have these, very large places, but they have very well trained staff. Certainly all the ones I've worked in, the maintenance staff are very aware of what the requirements are for the data hall. So having a calibration schedule is critical. As BEMS companies, we tend to have to work up strategies with the data center staff themselves, because there's some things they need us to do. There's some things that can be done in-house. But having that schedule to make sure that the sensors are still accurate is very important. And different sensors will require different levels of calibration. For example, a simple thermistor will probably only need checking. Check it once a year. It's really unlikely it's actually going to need any adjustments to it, because it's just a simple semiconductor. It's a thermal resistor. There's not a lot can change. Sometimes they fluctuate, but there's very little change. If you've got something with electronics in it, so if you've got an active sensor with some electronic components in it, or you've got a relative humidity sensor, a pressure transducer, something like that, There's a lot more that can affect those sensors. So you want to check them regularly and make sure that there is a scheme in place for recalibration. Very often that would need sending off site. So you need replacements on site so you can replace that device with one that you know is calibrated and send the other one off for calibration. Inaccurate data, poor control decisions. It really is as simple as that. We do a lot of training for the BCIA, the Building Controls Industry Association. BCMO2 is very much focused on control and measuring technology. And what we say is that, that inaccurate data, it leads to poor control, but it also leads to poor analytics. If you have got rubbish data going into your BEMS, then when you analyze that data, you will get rubbish coming out of it. So it's really important to get that accurate data in there. As a slight aside, just a little bit about communications protocols and integration. Very often in data centers, we're required to integrate equipment into bus topology networks. There are benefits and drawbacks to doing this. So there's a couple of things that we do. So one of the things is in terms of these bus communications networks, we will probably look at some metering in a data center, going back to the BEMS. That is required so that obviously we can see where energy is being used in the building. But we also get smart sensors, and smart sensors are great because they sit on a digital bus, and because they sit on a digital bus, they are lossless. You get the information passed down a digital bus, and it's in ones and zeros, so you get accurate information passed down the digital bus. If that information isn't received, so you get an error code, a CRC, cyclic redundancy check, which is not right, then you can request the data again. So they're really good from that point of view. But there are drawbacks to using smart sensors as well. You daisy chain them together, so you connect all those sensors together. If something happens, if someone snips a cable, then usually if they're in a data center and they've cut a cable, that's probably the last thing they'll ever do in that data center. But if it happened, then you would have all of the sensors after that would go offline. So it's not without its problems. But again, this can be dealt with by having redundant networks if necessary. They reduce installation cost. They provide more accurate data or lossless data rather than more accurate data would be a better description there. But you do need to factor in that element of it. There is also another factor with using communications protocols, and that is where we start to integrate these with the IT infrastructure. Data centers are incredibly secure places. I know at least one data center operator where if you are taking any cables across the roof of their building, then they insist that it cannot go in Cat6 cable, it cannot go in data cable. It has to actually go down to an RS485, a 2-wire cable across the roof, because if someone were to tap into that cable, they could potentially get access to the system, and that's a next level paranoid, but that's how serious that they take it. So if you're integrating your systems, you do have to think about security. Something which is proving to be very useful at the moment is LoRaWAN technology. LoRaWAN is long-range wide area networks. It wasn't developed until 2010, and so security is baked into LoRaWAN. So it is an IoT technology, but it's actually very difficult to hack into a LoRaWAN network. I mean, in terms of the layperson, I wouldn't even know where to begin to hack into it. But yeah, it's a very, very secure network. So we do have wireless technologies that can lend themselves to data center monitoring as well, with security built in. And all of this, if we're integrating with a BEMS or a SCADA, or what we would refer to as an ISN, an integrated services network, where it's physically segregated from all of the data networks, then of course we have segregation. We don't have the security issues. But if we are integrating with cloud services, with components which sit on the data network, then we do need to very much consider the cybersecurity of those sensor networks as well. And it's one of the reasons A lot of data centers actually prefer more traditional sensors where you've got thermistors and 0 to 10 volt signals coming back to more manageable equipment, rather than using these wireless and wired bus technologies. Choosing the right sensor technology, well, just choose a Sontay one, obviously. But beyond that, why? What particularly do you want to choose from the Sontay range? Range and resolution are really important. If you are choosing a sensor which has got an active output, a 0 to 10 volt output, it needs to be within the right range so that you get good resolution, accurate data. A really good example of that is with pressure transducers. So with a pressure transducer, you can get a pressure transducer which will do, if we're looking at a water pressure transducer, one that does 0 to 500 millibars, so 0 to half a bar. You can get ones that do 0 to 40 bar. Now, both of those will sense 250 millibars, but one of those is going to give you better accuracy because the resolution is better. If that 0 to 10 volt signal represents 0 to 40 bar, then 250 millibars is going to be a very small voltage, which is going to be very difficult to measure. Whereas if you've got the 0 to 500 millibar pressure transducer and you're looking to, within a working range of 250 millibar, that's 5 volts. So you get much better resolution. So choosing the right range and getting the right resolution for your sensors is really important. You also need to think about environmental tolerance. IP ratings, ingress protection, when you're putting something in an environment where there is potential for ingress against dust, so solids and liquids, you need to think about that IP rating. Typically, we associate that with components which are going on a roof and are therefore going to be subject to the weather. But we also need to think about other aspects as well. EMC resilience, so electromagnetic compatibility. Data centers have got lots and lots of fast switching circuits in them, and so EMC resilience is something that needs to be considered in these spaces. Now, with electromagnetic compatibility, one of the things that we try to do to minimize the problem of electromagnetic interference is create distance. And you see this all the time. When we're installing BEMS, you don't put your control cables and your power cables next to each other because the electromagnetic interference can cause problems. In a data center, again, space is something that needs to be in there. If you've got a sensor which needs to sense a cold aisle, you don't want to put it next to a lot of fast switching equipment, which could cause interference. It might work fine, but there is more potential there if it's next to that equipment. So we do have to think about the resilience to EMC, electromagnetic interference, and we also have to think about spacing those sensors out to make sure that doesn't become an issue. Response time is very important in data centers, particularly temperature sensors. Different temperature sensors have different response times. It's often misconstrued as an accuracy level for a sensor. If you've got a thermistor sensor, although it's very small, it's not as small as a sensor with which is known as an RTD, which is a resistance temperature detector, which is made out of platinum. And so platinum sensors respond much quicker than thermistor sensors, even though they offer the same accuracy. So if you're looking at dynamic response, then you say the air conditioning failed in a data hall. The platinum sensor will respond much more quickly to that rise in temperature. Eventually, they'll both get up to the same temperature, but if you need to raise an alarm when you're getting up to a particular temperature, then you're going to be wanting to use the right sensing technology in order to do that. So choosing the right sensing technology for your response time is very important, depending on your needs. Platinum sensors are made out of platinum. They're more expensive than thermistor sensors. But if you are saving millions, if not billions of pounds worth of data, it seems like a small price to pay. So thinking about that is important. Drift over time as well. Now, this goes back to the calibration regime. Sensors do drift over time. Thermistors drift by a very small amount, but they do tend to drift. They have electricity running through them and they break down a little bit over time. If you've got electronic devices, there's a lot more going on there. They tend to drift more quickly. I would sort of suggest by a greater magnitude, but it's not huge. But you need to think about that, and you need to factor that in to your calibration regime. Another thing, of course, is on the commercial side, the maintenance of those sensors. How do we get to them? Who can replace them? The serviceability. And the warranty. You're going to be wanting to work with a manufacturer who offers a very long warranty on their equipment, because hopefully you will never need that warranty. But if someone is offering you a 5-year warranty, then it means that they have a lot of confidence in their product to ensure that that product is going to work. They are very confident they're not going to be swapping it out every 5 minutes. It's a product which is designed to last for a long time. So choosing the right sensing technology partner is going to be really important in terms of the commercial and ongoing aspects of managing your data center. On the subject of redundancy, the redundancy is something that you can start. It can balloon very quickly into something very, very unmanageable. I've seen systems before now. So when you're setting up a BMS, what you tend to have is a controller with lots of I/O modules. And I've seen systems where they want 2 controllers, and every I/O module is replicated. But if an I/O module fails on one, it can actually go to another controller, and then all the sensors are replicated as well. And like I say, it balloons into this. What is ultimately a quite pointless system. You need to understand what level of redundancy you need, and then what is a sensible way to implement that redundancy. If you have got 2 sensors and they are connected to different controllers in your BEMS network, that is usually enough to give you the redundancy you need. Part of that is if they're connected to different controllers, and you've taken the trouble to make sure the controllers are connected to different power supplies. I mentioned about UPS power supplies in data centers. There's usually an A and a B UPS, so that you have redundant power. If you've got one controller connected to the A, one controller connected to the B, one sensor connected to the A controller, one to the B controller, then you've duplicated your data adequately. You don't need to do all this stuff with changing the I/O modules so that one of the B modules can work with an A module, etc., etc. So having dual sensors is about having the sensors but also connecting them to the right place, and how you manage that data when it comes in as well. Another useful thing about having dual sensors is that you can check the values of 2 sensors one against the other, and you can see whether they match within the tolerance that you're expecting, and you can get an early warning of whether one of those sensors is failing. In terms of monitoring solutions, failover logic is obviously really important. What happens if a sensor fails? So we need to know what the operational parameters are of a sensor. If one of your sensors suddenly starts reading 150 degrees C or minus 50 degrees C, we know it's failed. We need some logic in place to switch over to the redundant system, so we negate that sensor from there. And of course, we need a really good alarm monitoring strategy as well, so someone knows about this, someone can see that that's happened, and they can get that sensor replaced. The geographic sensor distribution is going to be very important. Already looked at hot aisle, cold aisle, looking at the differences in temperature above the racks, below the racks, etc. And also beyond the sensors, we need to think about that BEMS redundancy. As I've said, if you've got one controller connected to a UPS, one connected to the B UPS, then we've got everything we need to ensure as much redundancy as we can get. Bearing in mind that data halls are pretty huge. If you're getting a failure of your A power supply and your B power supply, the BEMS is going to be the least of your worries at that point. Just want to sort of finish, got a couple of slides on the data quality of analytics, and then some sustainability stuff. So real-time monitoring alerts is really important. Alarms in data centers. If something goes out of condition, you need to know about it. But you also need to analyze trends for maintenance and also for long-term trends as well to see what's happening in that data suite. If technology is changing in the data center, then you need to be able to adapt your environmental equipment to ensure that you can manage that equipment. It may be that it's generating more heat. It may be that it can run at a higher temperature, but those analytics are going to help you there. And we're starting to see AI and machine learning factoring into this as well. There are certainly, I know there are data centers out there that are using AI to ingest sensor data and then to automatically adjust plant based on the information that is coming in. As I always say with AI, AI is artificial intelligence. It needs sensors to work. People have intelligence. I mean, some of the ones I meet clearly don't, but people have intelligence. But we need sensors, we need eyes, we need ears, we need a sense of touch in order to make this work. So with AI, sensing technology is hugely important to make sure that those machine learning applications work. This sustainability and energy optimization, if we can prevent overcooling, and overcooling is the real big energy issue that we have with data centers, then we can have energy savings. We can optimize airflow. We can change cooling set points to match the requirements of the space, the requirements of the equipment in the space without compromising the data hall itself. And we can also comply with things like BREEAM, the Building Research Establishment Energy Assessment Method, which is a means of testing the sustainability of a building, which is a very difficult thing to do with a data center, because with a data center, obviously it's very, very energy intensive process, but you can still meet with these net zero goals and with these BREEAM requirements. These case studies, it's really difficult to find actual case studies with data centers because they're so secure. So this is quite notional data. It's based, it's almost anecdotal. I'm told it's real, but no one would tell me where it came from because they're so secure. There is a data center that I've been told about where they were overcooling, uneven temperatures, and it led to high energy use. What they actually did was it was a wholesale upgrade of sensors. They put sensors in the cold aisles, sensors in the warm aisles, looked at the stratification. And after the sensor upgrades, when they were sure the information was accurate, they optimized the airflow. They actually reduced the amount of cooling unit runtime and saw an 8% energy saving. I couldn't get out of the person what that equated to, but I would imagine we are talking multiple thousands of pounds if you're looking at an 8% energy saving. That was done. Yes, the BEMS had to be reprogrammed, but that was done through putting new sensors into the place. You get more information, you get more accurate information, then you can make your decisions, and those can equate to some significant savings, cost savings in your operational costs. In terms of future trends, it's very difficult to predict how the future is going to go. If I could, I'd just do the lottery numbers and then you would never see me again. But we are sort of seeing lots of trends here, particularly with IoT technologies. I hate the term IoT, Internet of Things. It's like, really? You couldn't think of a better name? But microsensors, LoRaWAN sensors, things which connect directly to the cloud. So that we can feed these into analytic systems. Integration with AI-driven control systems as well. AI is really having a huge impact on every aspect of our lives, but it is reliant on accurate information. And sustainability reporting as well. As we go on, it doesn't matter what people's views are on whether, what's causing global warming. Global warming is happening, and we need to think about how we deal with this. And so driving down carbon emissions, sustainability is a hugely important part of this, and legislation is only going to get more restrictive in terms of our sustainability. And so driving down energy consumption, driving down energy costs is also going to help us achieve our sustainability goals. I've left out this edge analytics because it's just too weird for data centers. Edge analytics is where you are actually doing your analytics rather than in the cloud. You're doing it at the edge of your data network. Data centers are the cloud. They're not actual clouds. So it's very difficult to define what, where edge analytics are. If you're doing your analytics inside a data center, it could easily be the cloud unless it's a closed off data center, in which case it would be considered edge analytics, on premises analytics. But analytical engines looking at that data are certainly something that we're seeing now, we're going to see more and more of, and this is going to be driven by AI more and more as time goes on. So just a quick summary, the right sensors equals uptime and efficiency, not necessarily in order of importance, but I would say they had equal weight. Efficiency drives down your costs, uptime, ensuring that you've got uptime is clearly important in terms of no losses from having PC or computer downtime. Redundancy will give us the reliability, and the data that we get from sensors drives the optimization and sustainability of our data centers, of which there are more and more as time goes on. And again, I would cite K-pop Demon Hunters as the root of the cause of this particular problem. And now you're going to be singing Golden for the rest of the day. So thank you for your attention. If anyone's got any questions, then there is a Q&A on Vimeo. I've actually got Phil and Lizzie standing by if anyone needs any questions specifically for Sontay. If anyone has any questions that they want to type in there, or me to field, then I can do that now. Usually give it a couple of minutes, and then I see that people are just leaving and going make a coffee, so then we end the session. So yeah, if you do have a question, now would be the time. If you think of a question later, you want some more information, of course, Sontay.com, they have a website, you can contact the team there. I'm on LinkedIn. As far as I'm aware, there's only one Andy Camsell doing this, so I'm pretty easy to find. So if you do need me, then send me a LinkedIn request, and we can connect that way. If there are no questions, and there don't appear to be any here, I'm going to turn that feed off. And thank you for your attention now, or if you're watching this in the future, thank you for downloading or watching the stream of this. And hopefully I will catch up with you on another webinar, which probably about 2 or 3 months from now. Failing that, if you're at Smart Buildings in Excel, maybe we'll meet in person. Thanks for your attention. Have a great one.